Okay, this is a section in which you want to go and get your favorite drink, because this is going to be a little bit long and it is involved, and you do need to pay attention. So make sure you're awake when you listen to all this new information in here. Okay, just a reminder, a regular polygon is a polygon where all the sides are congruent and all the angles are congruent. The center of the polygon is the center of the circumscribed circle. The beauty of a regular polygon is it can be inscribed in a circle. You can try that out in Sketchpad if you like. So going back to the regular polygon, here, it's a hexagon, I believe. It is inscribed in a circle, and so P is the center of the circumscribed circle, and we actually use that point P as the center of almost the polygon, even though we don't see the circumscribed circle each time. New word, apothem. Okay, let me repeat that. Apothem. An apothem is the altitude of a triangle in a circle where the triangle is made up of two sides that are the radii. So look at M, side M and side P. Side M and side N are radii, therefore they are congruent. So let me mark that. These are congruent. So triangle PMN is isosceles. Segment PQ is the apothem, and in an isosceles triangle, the apothem, which is also the height of this isosceles triangle, will divide the base, which is MN, into two congruent parts, which are MQ and QN. So MQ, let's try that again. MQ equals QN. That's a very important fact to remember. And since the vertex where the two congruent sides or legs meet is the center, therefore the angle, let's use a different color here, MN, angle MN is a central angle. Furthermore, we can find the measure of angle MN, the central angle, which is also the angle at the vertex, that is at the center of the circle, by dividing 360 degrees by the number of sides. So that's 360 degrees divided by 6, and in this case that is 60 degrees. Okay, that is all very well. So very quickly, let me go ahead and draw that triangle over here. Well, that didn't work too well, did it? So let's try again. And I have deliberately drawn this in a different orientation than you may be used to, simply so that you're not thrown out when it is shown to you that way. So I'm going to draw this, and I'm going to say this is PMN. We know these are congruent. Okay, we also know that the base angles are congruent as well. I'm now sketching the apothem. Okay, and that'll make a right angle here. So this is the apothem A. This is a common side. If you look at triangle MPQ and NQ, or triangles MPQ, you will notice they are congruent by hypotenuse leg. This is the hypotenuse, and this is the common leg. So those two are congruent. Therefore, it follows by CPTC that these angles are congruent. What you need to take away from this is that the of an isosceles triangle that is part of a regular polygon divides that center angle into two congruent halves. What does that mean in this case? In this pentagon, we said that angle, oh, I don't want red. Okay, so angle, try that again. Angle MPN equals 60 degrees. Therefore, angle QPN equals angle MPQ. Ooh, I need to say measure here, don't I? Measure is equal to 60 degrees over 2, which is 30 degrees. Alright, let me highlight well, difficult decisions. Okay, MN is the side, and I'm going to label this. This is the side from here to here, and these are radii, R and R for radius. Okay, just so that you remember. So these angles are now 30 degrees each. Okay, you are going to remember these are angles that are more complicated. Now girls, I want you to think about this. If you were given in this triangle any one of whether you were given R or A or S, you could use the knowledge you have acquired about special triangles to solve for the other variables. Like if you know R, you can solve for A and for S, which is the side. Of course, you can always use trigonometry. So what is the area of a regular polygon? Think about it. There are as many triangles as there are sides in a polygon. So the area of a polygon, a regular polygon, is going to be n, which is the number of triangles, times area of each triangle. And if you remember, if we take up that one isosceles triangle, oh, this is horrible. So let's try this again. Okay, and the height. Okay, so if I call this H, sorry, not H, I want to call that, it is the height, but the height is called A, the apothem. This is the radius, and this is the base. Okay, so the area of each triangle is base times height divided by 2. And I seem to be stuck on h height, and I'd like to arrange it in alphabetical order, that is a n s over 2. What is the perimeter of the polygon? The perimeter of the polygon is number of sides times the length of each side. And if you look at this and look at that, area is also AP over 2. So now you have the formula for finding the area of a regular polygon. And over here, there is just a little reminder on how to find the central angle.